The GCC has long dominated the global hydrocarbon market and continues to play a critical role in shaping the direction of the industry. With its vast oil and gas reserves, the GCC remains well placed to power both the upstream and downstream sector and set the agenda for a greater push towards cleaner energy adoption locally, regionally, and globally. The story of oil in the Middle East is not a contemporary tale, but began a long time ago. The first oil discovery in the region was in 1931 at an oil well in the remote Jebel Dakhan area of Bahrain. Soon, one by one, each of the other GCC countries made their own discoveries, paving the way towards a radical transformation across the region. And then in 2016, a new regional initiative was undertaken to further strengthen the association of these countries, and Bahrain was chosen as its headquarters due to the kingdom's strategic location. The Gulf Downstream Association, or GDA, was founded by Saudi Aramco, Bahrain Petroleum Company, Kuwait Petroleum International, Kuwait National Petroleum Company, and Abu Dhabi National Oil Company as a non-profit organization that will serve as a catalyst for strong and sustainable growth of the downstream industry and provide a viable platform for knowledge sharing and best practice.
The idea of GDA started a few years back, mainly to promote the cooperation and the coordination between the oil industries in the downstream field to ensure that we have a vehicle within the GCC to share practices, share lessons learned.
The Gulf Downstream Association, it's bring a lot of experience of industry. We are focusing into bringing these experience together and putting these company into the perspective and its real position in the oil and gas industry.
GDA's formation provides the springboard for effective partnerships across the region that will build on the strengths of each member organization in preparing a world-class workforce that can meet the challenges of tomorrow. And most crucially, help in creating a voice for the region on international platforms by being innovative, by creating a knowledge hub, and serving as a reference point for all stakeholders.
Our approach is very simple. If I have an area of excellence that I've excelled in, then it only makes sense that among the different companies within the GCC that we will be able to share and all of us excelling at the same time.
The key to GDA's long-term success will be the values that guide its operations, as well as the main propositions that drive its appeal.
Year 2018, we are looking to develop other conferences that will add value to our founding companies and members.
Members have access to a rich repository of valuable information through GDA's very own portal, possibility to attend or opportunity to conduct industry-related technical or leadership events, share knowledge and experience and adopt best practice to pave the way for greater sustainability that includes tapping the invaluable expertise of the senior transitional workforce, enhance communication between members to help foster good relations with global industries and associations, provide a voice for members to strengthen the three pillars of strategy: industry, government, and education.
GDA will provide for us an excellent forum to achieve operational excellence in our respective companies in areas like maintenance efficiency, personal efficiency, energy efficiency, as well as capital efficiency and project execution.
The GDA is starting with the Arabian Gulf, of course, but we are also starting big, and we're already interacting with all the multinationals. And the technologies are really going to be an important part of our membership portfolio, the EPC as well. And this is where we feel our strength is, by getting the stakeholders together, networking, identifying the business and technical challenges.
GDA is poised to be the perfect platform for future generations in the GCC. For the youth in the oil, gas and refining sector, it will prepare them for tomorrow's challenges, as well as help them manage the daily hectic demands of this innovative and rewarding industry. The choice is now in our hands. Opportunities are all around us, and together with the GDA, we can create a stronger and more sustainable downstream industry. GDA. Share and excel.
Hello and welcome to the 14th episode of GDA Conversations, brought to you by Gulf Downstream Association. My name is Raj Hajaria, Technical Manager with GDA. As you know, during this crisis, GDA has been trying to build many knowledge bridges between the industry leaders and downstream players. GDA Conversation is one such attempt through which we are virtually connecting with people who could share their knowledge and improve our sustainability and profitability in the refining industry. Today, we are very fortunate to have three speakers from a recently launched joint venture company called Shell and AMG Recycling. This joint venture is between Shell Catalyst and Technologies and Advanced Metallurgical Group, AMG. From this recently established joint venture, we have three great speakers. Our first speaker is Mrs. Jane Neal from Pittsburgh, USA. She is the Senior Vice President of AMG Vanadium. She leads several teams related to environmental, H&S, health and safety, quality, continuous improvement, and vanadium sourcing. She has more than 20 years of experience. She is a holder of Six Sigma Black Belt. She has a bachelor's degree in metallurgical engineering from Ohio State University. She also has an MBA degree from West Virginia University. Currently, she is playing the role of a chair in Ohio Manufacturers Association. Our second guest is Mr. Kevin Jones, also from Pittsburgh, USA. He is the VP with AMG Advanced Metallurgical Group. He has more than 30 years of experience in metal industry. Before joining AMG, he was the president and CEO of Gulf Chemical and Metallurgical Corporation. And before that, he was the founder and CEO of Bayer Metallurgical. He has a bachelor's degree in marketing from the University of Florida. Also, he has an MBA degree from the University of Pittsburgh. And our third speaker is Mohammed Benchekchou, and he is joining us today from Dubai. He is the Director of New Business Development, MENA region for this new joint venture. He has more than 20 years of experience in sales, business development, consultancy, refining technology, and catalyst technical services. He has dual master's degree in refining and chemical engineering from IFP School, Paris. Together, these three speakers have chosen a very interesting and contemporary topic which interests all our refining industry. All refiners today are faced with a challenge of improving margin, reducing carbon footprint, and utilizing circular economy. All of these challenges will be addressed today in the topic which they have chosen, creating a value through a proven circular solution for refining spent residue upgrading catalysts. So without further ado, let me introduce our speakers today. welcome Mohammed, welcome Kevin, welcome Jane. We hope you are keeping safe and good health. And with that, let me hand over to Mohammed to lead the conversation. Mohammed, over to you.
Thank you very much, Raj, for your nice introduction and for setting the scene for today's conversation. Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Good afternoon, good evening, and very good early morning to all of you who have made it today. I know it's a bit early for some of you, our participants, calling from US, for instance. My sincere apologies for that. I hope you will all enjoy today's discussion and conversation. Before I start the subject, let me first start by expressing my hope that you and your colleagues are staying healthy during these unprecedented times. It is indeed a challenge like most of us have never experienced before and tests us in ways we could not have imagined a few months ago. I wish you continued strength to come through to better times, perhaps even stronger than before. Let me also thank Raj and his entire team from Gulf Downstream Association, who have kindly accepted to organize and host this webinar under GDA umbrella. As permanent member of GDA, in Shell, we believe that there is a lot to be shared among operators, technology, and service providers. GDA will certainly continue to play a big role to make this happen going forward. Today, we are going to have a new GDA conversation about creating value through a proven circular solutions for refining spent residue-upgrading catalysts. Well, let me walk you through this cautionary note. I'm not going to read the entire slide, but there are some key notes that I'm obliged to read through. This webinar could contain forward-looking statements about Shell and AMG Recycling. Forward-looking statements are not historical facts, but may include statements concerning Shell and AMG Recycling plans, expectations, competitive strengths and weaknesses, and future operations and developments. Our business strategy and the trends Shell and AMG Recycling anticipate and other similar or different information that is not historical information. When used in this webinar, the words like expects, believes, anticipates, plans, may, will, should, and similar expressions and the negative thereof are intended to identify forward-looking statements. By their very nature, forward-looking statements involve inherent risks and uncertainties, both general and specific, and risks exist that any predictions, forecasts, or similar projections contained by such forward-looking statements will not be achieved. These forward-looking statements speak only as of the date of today's webinar. Shell and AMG Recycling expressly disclaims any obligation or undertaking to release publicly and updates or any updates or revisions to any forward-looking statement contained herein to reflect any change in Shell and AMG Recycling expectations with regard thereto or any change in events, conditions, or circumstances on which any forward-looking statement is based. Oof, I passed the test. So the reason we have called for this webinar is to engage with refiners of this region to discuss the opportunities associated with the proper management practices of spent catalysts and the refinery waste. We want also to discuss the resulting benefits to closing the loop on the circular economy and enabling significant contribution towards renewable energy and greenhouse gas reductions. At the same time, reducing long-term risk for the refinery, a generator of these waste streams. Jane, Kevin, and myself will cover the agenda as you can see in this slide. I will start with a very quick introduction about both companies, Shell Catalysts and Technologies and AMG, and then I will explain one, why we have got together as a JV, and two, what is the chief objective of the JV in the region. Let me start with Shell Catalysts and Technologies. Well, as a brand, Shell Catalysts and Technologies has been in the market since April 2018. But as a business, It has a long track record through its predecessors companies, namely CRI, Criterion, and Shell Global Solutions. These three legacy brands have supported Shell and non-Shell refining and petrochemicals businesses since the last 3 decades. Shell Catalysts and Technologies' chief objective is to support our customers by working with them to co-create integrated and customized catalyst and licensing solutions. When it comes to residue upgrading or bottom of the barrel operating units or projects, whether using ablated bed or fixed bed, as an owner operator, we in Shell, we can proudly say that supplying catalysts and supporting our customers for both of these technologies have been our bread and butter for the last 3 decades. We have 5 manufacturing plants, fresh catalyst manufacturing plants, actually 3 in the US, 1 in Belgium, and 1 in China. We have 3 research centers, 1 in India, 1 in Netherlands, and 1 in the US. And we have sales and technical services locations in all over the world, in Canada, China, Dubai, India, Netherlands, Russia, Singapore, UK, and USA. Okay, what about AMG now? Well, AMG is a market leader in reclamation and recycling of spent residue upgrading catalysts since many years. AMG process spent catalysts in an environmentally sound way for many years in North America. The background photo, you can see in this slide, is AMG spent catalyst recycling facility located in Ohio in the US, which is one of the 3 AMG operations that produce vanadium products from the recycling of petroleum wastes. The second facility is currently under construction in the US, effectively doubling AMG spent residue upgrading catalyst capacity. Finally, the AMG titanium alloys and the coating facility in Germany produces very high purity vanadium master alloys for aerospace and chemicals for catalysts, electrolyte for vanadium redox flow batteries, and other specialty applications. Kevin will tell you more about these applications in his part. First question is why Shell Catalysts and Technologies and AMG got together? Well, from Shell Catalysts and Technologies perspective, we saw the large growth in global demand for our market-leading residue upgrading catalysts, whether it's fixed bed or ablated bed. In the next slide, I will show you how this growth looks like, especially in this region. Bringing 2 global leaders in manufacturing of fresh residue upgrading catalysts and management of the resulting spent catalysts will help refineries by benefiting from an end-to-end value in a sustainable manner. In short, our objective is to build a state-of-the-art recycling capability for spent residue upgrading catalysts and gasification ash in the Middle East using AMG technologies. The idea here is to turn a problem into an opportunity that will allow refiners to find a home to their refinery wastes, I shall say, whether for spent catalyst or gasification ash, by using an environmentally sound management system. By doing so, not only we will be able to produce valuable products that my colleague Kelvin will cover later in his presentation, but also to contribute to the circular economy of the main components of this catalyst, spent catalyst, which is vanadium. We do all this while decreasing CO2 footprint, avoiding landfill, and support the local economy. Before I hand over to Kevin, I would like to leave you with this graph that is self-explanatory. While it looks promising from business perspective for refineries and technology and catalyst providers, it is kind of frightening. Why? Well, especially if we as leaders in this region stay still, and rely on other regions to process the resulting spent catalyst produced in the Middle East. The graph shows where we are today and where the spent residue-upgrading catalyst volumes are heading. Today, they are already operating units as we speak. This is the baseline, as you can see in the left-hand side of the graph, at 100%. In the very short term, really short term, talking about 2-3 years time from now, 2021 to 2023, some units are planned to be commissioned. Others are being built and will definitely be on stream before even 2023. Here we are talking about a factor of 6.5. This is just astonishing. Down the road, we are talking about a few bottom of the barrel projects that have already selected catalytic solutions for their bottom of the barrel projects. Although the FID have not been confirmed yet, but some have already selected the licensor and are talking about catalyst supply and spent catalyst options already, whether for residue upgrading in a fixed bed or in a nebulated bed. Okay. Well, with that, I'd like to hand over to Kevin, who will take you through the rest of the presentation along with Jane.
Okay, thank you, Mohammed, and thank you, Raj, for getting us started here today. Good afternoon. My name's Kevin Jones, and I am Vice President for AMG Advanced Metallurgical Group, and I'm responsible for the Shell and AMG Recycling JV from the AMG side. I have over 30 years experience in the ferroalloys and spent catalyst industries, and I'm honored to be here with you today. And I also appreciate your spending your precious time with us here today. A quick introduction on AMG Advanced Metallurgical Group. We are a portfolio of critical material producers and related technology assets, which in their respective niche markets are without exception global market leaders. We operate globally with approximately 3,000 employees and $1 billion in annual revenues. AMG's mission is to provide critical materials and related process technologies to advance a less carbon intensive world. As Mohammed mentioned earlier, AMG is currently under construction to double its capacity for spent resid catalyst processing in the US, where we're going from about 30,000 to 60,000 short tons annually. This new facility will be fully operational in 2022 and is the initial design basis for a plant in the Middle East region. Refiners in the Middle East have expressed a desire for Shell and AMG Recycling to construct a world-class, high health, safety, and environmental standards facility based on US EPA standards. And this is what we intend to do. Feasibility engineering work is already underway for this expansion in the Middle East region. In this rendering you see on the slide, I'll just point out a couple of main parts of the process. Number one is the spent catalyst storage building, which is designed with a double leachate collection system to manage oil and liquids that decant from the spent catalyst during storage to prevent release into the environment. This spent catalyst, raw spent catalyst, is then fed via conveyor belt to number two, which is the roasting operation, where carbons and sulfur are removed while converting the metals in the spent catalyst from sulfides to oxides. And the SO2 is captured in a high efficiency scrubber. Finally, number three, the roasted spent catalyst is then transferred to an electrical arc furnace operation where a duplex furnace system is employed. And in the primary furnace, nickel and molybdenum are selectively reduced and recovered as an alloy. And the vanadium-rich alumina slag is then transferred to a secondary furnace where ferrovanadium and calcium aluminate are produced. All of these products from this plant go into the steel industry. Okay, I want to quickly look at the vanadium market, which is the economic driver for the recycling of spent resid catalyst. The vanadium industry is small in total number of producers, where the 10 largest account for about 80% of global production, largely resulting from basic oxygen furnace or BOF steelmakers using vanadium-containing iron ores. This source represents about 70% of global production and occurs in China and Russia. Over time, this method of vanadium production is likely to decline as steelmaking technology continues to evolve from BOF technology to electrical arc furnace, or EAF technology. Vanadium is also produced from primary mining, where ore is mined and processed for the sole purpose of producing vanadium, and this represents about 18% of global production. Finally, and the most relevant for this audience, is vanadium production resulting from the processing of petroleum products and crude oils. This source represents about 12% of production today. Unfortunately, much of this recycling capacity is in developing economies with little or no environmental standards to speak of. Over the next decade, vanadium production from the recycling of petroleum waste will see significant growth. Moving on to vanadium consumption, you can see it's steadily growing, driven by China, where recent requirements have been put in place to require high-strength rebar to be used in construction due to the seismic activity in China and the horrific loss of life due to building collapses from earthquakes. In the period shown here, vanadium consumption has grown by 25% globally, with a significant part of that coming from China. We expect Chinese growth to continue as the adoption of the revised rebar standards are implemented and enforced. High-strength steel is where almost 90% of vanadium is used today. Vanadium increases the strength of steel, enabling 20 to 40% less steel to be used to satisfy the same engineering needs, resulting in lighter and stronger structures, enabling energy and fuel efficiency. About 2/3 of the world's population lives in underdeveloped and developing economies, where huge amounts of steel will be needed over the next decade and beyond to industrialize these nations. High-strength low-alloy steels will be used extensively in countries like India, Indonesia, Brazil, Pakistan, Nigeria, and other highly populated countries that will evolve into industrialized economies in the future, driving the demand for vanadium to new levels. It's also interesting to note that, for example, in Kuwait and Saudi Arabia, there are very ambitious goals to be reached by 2030, and these ambitions will require significant amounts of high-strength steel as well. The remaining 12% of vanadium goes into aerospace applications in the form of master alloys for titanium, into chemicals used for catalysts and many other applications, and electrolyte for vanadium redox flow batteries. It's also worth noting that only a very small percentage of vanadium producers today can produce high purity vanadium pentoxide for chemical and aerospace applications. The World Steel Association includes the countries shown on this chart in their crude steel production statistics for the Middle East region. Crude steel production has more than doubled over the last decade in the Middle East, and this trajectory is expected to continue. The amount of vanadium used per ton of steel is referred to as specific consumption or the intensity of use. The Vanadium International Technical Committee, also known as Vanatech, and its members estimate the current intensity of use to be 0.03 kilograms of vanadium per ton of steel in the Middle East region. This is the lowest of all reported regions globally, as you can see in the chart on the right. It is expected that the intensity of use in the Middle East region will increase to the world average over the next decade. And if crude steel production continues to grow, where let's assume it increases by another 20 million tons by 2030, then vanadium consumption in the Middle East will increase from about 1,200 metric tons vanadium today to over 3,600 metric tons by 2030, or triple the current level of consumption in steel. Of course, the latest application for vanadium is energy storage, particularly the vanadium redox flow battery used for large grid-scale energy storage, of which vanadium pentoxide is the main ingredient. Renewable energy expansion requires a proportionate expansion in electricity storage capacity. This is because renewable production is highly volatile. Wind blows or it doesn't, and the sun shines or it does not. Traditionally, large-scale electricity storage has been provided by hydro pump stations, pumping water up during the night using surplus electricity from continuous fossil fuel and nuclear power plants, and releasing electricity during the day. In the renewable energy world, that does not work, especially given the growth in electric vehicles, where EV drivers come home and charge their cars at night, and nuclear and fossil fuel production is on the decline, compounding this dilemma. This completely upends the supply-demand balance that made hydro storage feasible in the first place. Going forward, vanadium batteries are the most competitive solution for battery-based electricity storage systems. This is a transformational market opportunity for Shell and AMG, since we are expanding the vanadium supply and will produce high-purity vanadium oxide for use in batteries. Now we'll move on to the subject of spent catalyst management. AMG applies the world's most stringent standards for spent catalyst management and reclamation to its operations. In the US, spent catalyst is a listed hazardous waste, meaning that any handling, treatment, storage, transportation, or disposal of the material is highly regulated by law and permit authorizations. I'm now going to turn it over to Jane Neal from AMG Vanadium to tell us more about proper management practices related to spent catalyst.
Thanks, Kevin. I'm Jane Neal. As Senior Vice President at AMG Vanadium, I engage with our refinery partners to establish catalyst service contracts, as well as leading the AMG Vanadium environmental health and safety teams. Catalyst reclamation must be done in a very safe and environmentally sound manner. In addition to the hazardous constituents contained in spent catalysts, such as benzene, arsenic, and antimony, the US EPA listed spent catalyst as a hazardous waste because it can exhibit pyrophoric or self-heating qualities. In 2017, China banned the importation of several types of waste to avoid being used as the world's dumping ground. The ban specifically prohibited imports of spent catalyst that contained vanadium. But some brokers are circumventing the rules, using tactics such as classifying catalyst as a metals concentrate. Refiners need to ensure their material is appropriately identified for purposes such as the Basel Convention, OECD, customs, transportation regulations, or the International Maritime Dangerous Goods Declaration. In case of doubt, you should be conservative, as countries are becoming stricter in the enforcement of hazardous waste regulations. The Basel Convention requires advance notification by the exporter and consent from the importing countries for transboundary movement of waste. We've seen unroasted spent resid catalyst being labeled and classified incorrectly in order to avoid notification requirements. The vanadium concentrate classification is often used, but we've even seen the spent catalyst labeled the same as fresh catalyst, while it's clearly not the same material. Also, if shipped by ocean vessel, spent catalyst, whether raw or roasted, should carry an IMO dangerous goods declaration. We encourage you to beware of catalyst processors and brokers using inaccurate shipping classifications or designations. They might be putting your company at risk. Shell and AMG Recycling believe it's our duty to share our knowledge of the catalyst recycling industry, the legal and environmental risks, and the rationale for applying AMG's best-in-class practices to resid spent catalyst recycling and metals reclamation. Shell and AMG Recycling is an environmental service provider. Our top priority is to mitigate environmental risk and liability for the oil refineries. Whether you ultimately select Shell and AMG Recycling or another processor, make sure best-in-class practices are being utilized. The processor should demonstrate that they have the facility and systems in place to handle your material responsibly, being protective of the environment. Confirm that they're responsive to regulators and respected by their community. Make sure that they have funded adequate financial assurance to cover the potential closure of the facility. Whatever they don't have covered can become your liability when they close. Understanding your processor starts by asking questions, but should include visits to the site to validate their claims, both before you start the relationship and periodically thereafter. Refiners need processors to recycle their spent catalyst and have occasionally opted to roll the dice by supporting unproven technologies or lower quality ventures, while turning a blind eye to the processor's waste management practices. The refiner needs to understand where all the byproducts and waste generated by the recycler will go, because the generator retains liability for all of them. This is why AMG maintains a conversion rate of over 99% to saleable finished goods. That is the only way to eliminate that ongoing liability. Dozens of spent catalyst reclaimers have filed for bankruptcy and simply disappeared over the last couple of decades. Some of these created significant liabilities to the generators. The cleanup cost for these Superfund sites ultimately comes back to the generator, who will be held liable as a partially responsible party, whether the catalyst was transferred to the facility directly or through a broker. The refineries may even be held liable if they were told the processor was following the law, and sometimes even if the practice was legal at the time but has since become illegal. There are many examples of spent catalyst reclaimers filing for bankruptcy after being convicted of environmental violations. Unfortunately, the refineries who delivered catalyst to these companies paid not only in the cost of site cleanup, but also in damage to their reputation from the negative publicity. The point here is that using low-cost recyclers or unproven technologies is a risky proposition. Long-term financial stability should be a high priority when selecting spent catalyst management. Many countries have regulations for Superfund sites. In the US, under the Comprehensive Environmental Response, Compensation, and Liability Act, the regulations hold the generator liable for cleanup costs not covered by the posted financial assurance. Regulations in China also hold the generator liable for hazardous waste in perpetuity. You should be aware of the risks you're taking if you do business with an unproven entity. Research them well and ask the right questions. We've included many of those questions in the Risk Mitigation Handbook published on the SAR B.V and AMG websites. We offer this to the industry as a source of very good information and audit checklists that you'll find helpful. The first edition is based mainly on North American regulations, but we're crafting a version of this that will be more relevant to other regions. That document will be posted on the SAR B.V website. Shell and AMG Recycling offer refineries state-of-the-art options for recycling their vanadium-containing waste worldwide. This graphic shows the technologies we plan to build in the region using both hydrometallurgical and pyrometallurgical technologies. Here, vanadium will be produced both as a ferroalloy for the steel industry and as a high-purity metal oxide for the specialty and chemical markets, like the vanadium redox flow battery. With partners like AMG developed a methodology to measure the impact that our products and services have on CO2 emissions. Approximately 80% less CO2 is generated when producing a kilogram of vanadium by recycling spent catalyst than production by primary mining. And when vanadium is used to increase the strength of steel, designers and engineers can reduce the weight of steel required in a given structure by 20 to 40%, with a proportional reduction in CO2 generation. AMG continues to refine its methodology for measuring greenhouse gas emission reductions and believes that it will ultimately lead to certifiable CO2 measurements that refineries can use to monetize as carbon markets are deployed globally. We were often asked about the economics for spent catalyst recycling. Due to the antitrust concerns, we can't discuss the specifics of this issue in a forum like this, but I'll provide some broad considerations for this very complex subject. There's currently a severe shortfall in sustainable catalyst recycling capacity, and the cost of constructing a world-class recycling operation is significant. The capital investment requirements for a project in the region depend on many factors, including the technology choice and capacity. Spent catalysts are liquid-bearing, pyrophoric hazardous waste, and the cost of packaging and shipping them are high. This has a significant impact on the economics of recycling. Other key factors in the financial cost benefit of recycling include the metals content and levels of undesired elements in the catalyst. Metal market prices are another important variable that is outside the control of both the processor and the generator. But the one factor that is rarely included in the evaluation is the value of environmental stewardship. Refiners need a processor who is committed to safe and environmentally sound practices in good times, and more importantly, in the economic downturns. Choosing a processor based on short-term financial gain leaves refiners exposed to the substantial future financial and reputational costs. Select a partner with a proven commitment and the financial strength to protect your future. Thanks, Kevin.
Thanks, Jane. This concludes the presentation portion of today's webinar. But before we move on to the Q&A session, I wanted to make a brief observation that occurred to me as I listened to the presentation here today. With the ever-increasing importance of climate policy, it's not only ironic, but it's also very illuminating that Middle Eastern oil producers, like yourselves, have the ability to make a significant contribution toward the circular economy, where the recycling of refinery wastes contributes to CO2 reduction and aids in the attainment of renewable energy goals for the region. By choosing to recycle these wastes with Shell and AMG Recycling, you are truly creating a circular economy where energy storage is debottlenecking and supporting the growth in renewable energy. There was a journalist who recently wrote an article about this and said this is closing the circle and named it the greening of the desert. I find this very fitting and pertinent to today's discussion. I commend and thank all of you for being here today, which shows your concern for doing the right thing when it comes to managing your waste streams in an environmentally sustainable manner and choosing a reputable partner for doing so. Raj, I'm going to turn it back to you now to kick off the question and answer section.
So thank you once again for this great presentation. I understand that both AMG and Shell came together for a winning equation, win-win for both, and probably also for the winning industry. Are there any other background you would like to share, Mohammed, how the Shell and AMG came together?
Yeah, well, thank you very much, Raj, for the question. I mean, in the first portion of the presentation, I explained about the global demand, right? In residue upgrading catalyst going forward. That is a response to the IMO specifications, to the bottom of the barrel project. Some refineries, they want to comply. Some refineries, they want to take this as an opportunity to further upgrade and get more margin out of their bottom of the barrel. So during the discussions with most of our customers in the region, we realized that there was going to be an issue due to lack of environmentally sound outlets for spent catalyst in the region, especially as Jane explained, the catalyst is a hazardous material, and the export of catalyst, transboundary is going to have lots of challenges. So over the last I would say a couple of years, many customers ask Shell Catalyst and Technologies for assistance with their spent catalysts. One of our customers has a huge growth, and we all know. So these units are being commissioned as we speak, or some of them are being constructed. So we've known as unknown AMG. So we have worked together actually for many years in one of our refineries in Canada that we operate. AMG as a market leader in reclamation and recycling of spent catalysts. Well, we've worked together, right, for over 17 years. So our journey to create a compelling reclamation and recycling value proposition started and ended with AMG. So we want actually to continue this journey together outside the US. So we have a couple of projects going on as we speak, Middle East as well as China.
Before I turn question answer floor to the audience, I would like to mention that we are truly honored today by the gracious presence of our chairman and VP Domestic Refining and NGL Fractionation Saudi Aramco, Mr. Suleman Al-Bargan, and also Deputy Chief Executive of BAPCO, Mr. Ebrahim Talib, and our Secretary General, Mr. Auda Al-Ahmadi. Thank you very much, all of you, to join us. And also we have a galaxy of experts from our member organizations and also invited guests from Shell and AMG. So the floor is open. Anyone want to ask a question, please, you are most welcome. I see one question from Mr. Firas Quilati. Mr. Firas, would you like to ask your question?
Yes, thank you. I just want to ask about how much the vanadium recovery percentage in AMG plants.
So, the recovery depends on the vanadium content of the spent catalyst or the gasification ash, of course. Our processes, both the hydrometallurgical and the pyrometallurgical processes, we believe to be the highest recovery levels globally. We have very, very good yields. And as Jane pointed out, we convert to saleable product 99% of the materials that come in. Now, that doesn't mean the overall yield is 99% of the vanadium, but it is very high.
Raj, Jane, Kevin, and Mohammed, thank you very much for a very exciting and enriching discussion about a critical subject that I'm sure all of us are very much concerned about. And I think the talk about this subject in particular may not have been an issue a few years back. However, as our industry is transforming and becoming extremely responsive and sensitive to the environmental concerns around the globe, I'm sure this is going to be a subject that will dominate many of our discussions in the future. Looking at where we are and how we stand in this part of the world, I think if I would maybe include what our colleagues in the GDA in general, be it the Saudi refining business, the Bahraini, the Kuwaiti, the Emiratis, and basically a lot of what we do in the Gulf, we rely heavily on our partners to help support in the recovery, whether it is in different entities in the US and in the rest of the world. Our most recent experience with Jazan refining complex, where we have basically 20 tons per day of the soft ash recovery unit that we have. And again, this is, when you look at it from the logistical point of view, originally in our original plan, this was kind of maybe 6-7 years ago, we were basically thinking of dumping it. And I'm sure if you say that to you folks, I'm sure you will go crazy, because there's a lot of vanadium, a lot of good stuff in that material to be able to extract. However, as we went along the project, we start to realize that we need to encourage the recovery, and for that we went into a program to recover. And to be honest with you, in at least in Saudi Arabia, I'm sure to a great extent in many of the Gulf region countries, the need to localize becomes an essential element in how different partners and different companies are perceived. And so in Jazan's case, the deal is to, yes, maybe start with shipping some of that material out in the first few years. However, there is a commitment to build a facility within the area. In the case of Jazan, if the size permits, then building it in Jazan would be the most appropriate. If it is to encompass much more volumes kingdom-wise, then we are flexible on where would that be within the kingdom. And so that is, I think, it's interesting to see that you have shown the facility that you intend to do in the Middle East. And I think you have rightly pointed out that through the coming few years, the growth, especially once we implement our residue upgrade facilities that we intend to have in the coming 4 to 5 years, I think that would be the right move into the right direction. And localizing it within the Gulf region to be able to serve the needs in the Gulf is going to be a crucial deciding factor for the partners that will be chosen. And it's going to be the volumes, I think you've highlighted it. clearly, if we go with our plans, you're talking about almost 20,000 tons per year of residue upgrade, possible spent catalyst, which is a significant amount to be considered. And I think looking at it at this stage and planning for it ahead of time is going to be a very critical deciding factor to how this subject is going to be tackled in the future. So appreciate it, and thank you very much for very informative presentation and great discussion on this important subject.
Thank you, Suleman, and wise words and guidance for all of us. We have, I believe, a question from Mr. Anton.
Good afternoon and good morning, ladies and gentlemen. I'm from BAPCO. I just would like to know, with regards to recycling, do AMG consider other types of catalysts as well, or are they only focusing on resid-upgrading catalysts?
Our main focus is resid-upgrading catalyst, but we do, of course, recover nickel and molybdenum from that catalyst. So, you know, there is a possibility to in the plant that we showed you a picture of, process nickel and moly. We are not opposed to considering other types of catalyst and whether we can process those internally in a plant that we build in the region, or if we align with other sustainable partners like ourselves. But we would be happy to try to develop a management solution for all of your spent catalysts.
Right. Thank you. Thank you very much. While waiting for our participant to have some question, I have one question, perhaps to Jane. You said that this technology and the project will help refiners reduce their net carbon footprint. Could you throw some more light on it? How exactly would it help our refiners to reduce their net carbon footprint?
Like, so we've done a number of, we've done some calculations on all of this. And what we determined was that if you start with a catalyst that has about 10% vanadium in it, that for every 1,000 metric ton of spent catalyst that is processed through the AMG Vanadium pyrometallurgical process, we save almost 90 metric ton of CO2 from being generated. That's both from the processing side and from the enabling benefits of using vanadium in steel. It's significant.
Right. That's quite a lot. And also I understand that the recovery of vanadium itself will fetch value, adding into the circular economy for the refiners.
Absolutely.
And also the reduction of the hazard in the landfills.
Most importantly.
That's correct. So basically there is a winning equation all the way through. Ibrahim Talib. Yes, Mr. Ibrahim.
No, so I just again want to echo our dear friend and guru Abu Amar's points. This has been very informative, I think, going forward. And I've already, of course, personally, I did touch on with the Shell team at some stages. And I think there's definitely, this is some very promising options going forward for the future. So very informative again. Thank you.
Thank you, Ibrahim. Thank you very much. Nasiru from Saudi Aramco, please go ahead with your question.
Yeah, Raj, thank you. Actually, I have a colleague of mine here who has questions. We are listening to the presentation together. So his name is Frank. Frank, go ahead.
Go ahead, Frank.
Yeah, thank you very much. Very informative. My name is Frank Han, actually Aramco Process Control Department. I have a couple questions, one technical, one about regulation. So the first question is, can anybody describe what the difference between, the major difference between the gasification ash and also EB catalyst? And also, what is the determining factor to choose which technology routes to clean these metals, or either pyro or hydro. So how do you decide which one to go, right? First question. The second question about the regulation, I heard during the presentation, this spent catalyst classified as a waste, right? So and also I heard is a generator's responsibility to get reclaimed. So the question about if I have a processor, willing to take the stream to process it, is that still under the liability of the generator, which is the refinery in this case? These two questions I have. Thank you.
Sure. So Frank, you asked about the what decides the which process we will take, we'll use, whether it's a gasification ash or spent catalyst. Well, first of all, the gasification ash composition is quite different from spent catalyst, right? Spent catalyst composition is mostly alumina, and you've got 10 to 15% vanadium on catalyst and other metals. In the case of gasification ash, so you've got mostly metals. So it will depend on what we want to do with the products, right? Do we want to produce high purity vanadium oxide V2O5, or we want to produce ferrovanadium? Okay, so basically the AMG can process both streams in both processes. In the case of gasification ash, you don't have to go through a roaster, for instance, because you have hardly any carbon there. And for the case of spent catalyst, well, it has to go through a roasting process to remove the carbon, the sulfur, and before you start reducing the metals and recover your metal.
Yeah, Jen.
So with regards to the liability, the environmental liability for the catalyst, the regulators in many countries, including the US, leave that liability with the generator. So as you send your material to a processor, you never really lose that liability. That's part of the reason why it is so important to understand who that processor is, and to ensure that they have adequate processes, adequate financial assurance, because if they do close and the government is left to deal with that closure, then they're going to come back to the refineries who sent material to that facility.
Thanks, Mohammed and the other team.
Jean, Kevin, and Mohammed, thank you for a great presentation. Of course, you touch on a subject that everybody is keen about, and which is green energy and reduction of carbon dioxide, and to have clean environment. My question is, okay, how long will it take to build a facility? And before you build a facility, can anybody in the area use your recycle facilities, which is only now, as I understand it, only in USA?
Mr. Al-Bargan addressed some of this, and refiners in the region may not fully appreciate the tsunami of spent resid catalysts and gasification ash that's going to be coming out on a very regular basis. These are very large volumes, and there aren't currently any local solutions in the Middle East for this. So the time is really of the essence to get moving on this. Shell and AMG are in a position to move quickly. We're already doing our pre-feasibility work, and we'd like to move these projects forward to financial investment decision and get started on FEL3 and FEL4 engineering as soon as possible. And we are in a position to have some of our operating assets in place and operating as early as 2023. And from there, the timing really depends on the timing of the streams coming on in the region, and Shell and AMG Recycling having enough material under contract or confidence that we'll be able to get the material under contract. Our technologies are proven technologies, and we're building facilities based on our existing operations, in which virtually eliminates any technical risks whatsoever. So that's part of the answer. But go ahead, Mohammed. Do you have some thoughts?
No, I was just trying to clarify one thing. So, and as we clearly pointed out earlier, right? So the growth is huge, and we're not talking about probably one facility. It could be a mega center. It could be a couple of facilities, right? So the volume is so big that it can easily justify 2 times today's AMG capacity. Now, in the meantime, the question is what will happen, right? So it will take probably 2-3 years to get this on stream. Well, we will utilize AMG assets in the US to process the catalyst, but we will transport the material properly, as we said earlier. When packing, classifying, and shipping spent catalyst, well, we will call it hazardous material, hazardous waste, as required by the law. Doing so, we have to be clear between ourselves. It is going to be expensive, but again, it protects the refinery from the risks. Less scrupulous processors are willing to expose the refinery to. So we've seen this in many places. Myself, I've traveled to Asia Pacific, for instance. There are plants where, well, you don't want to put your name, you don't want to expose your companies to these risks.
And Mohammed, one other thing, I think part of the question is what do we do in the meantime? And I think the answer to that is you need to work with Shell and AMG Recycling. In the interim, we've got assets, AMG has assets in the US, and we're expanding them, as I mentioned earlier, and we would be happy to help manage these materials in the meantime until we have an asset in the region. But just know we're going to transport these materials properly. As Mohammed mentioned, we're going to package them and we're going to classify them, and we're going to ship them as hazardous waste as required by law. So doing it this way is maybe it's more expensive, but it protects the refinery from the risks of the less scrupulous processors, as Mohammed referred to, who are willing to expose you, the refiners, to risks that we don't want you to have to take on. So we're happy to help in the meantime.
This is David from Saudi Aramco. Basically, I would like to compare how we do things differently with the precious catalyst, wherein we send it to a reclaimer, we pay the service for processing it, but the platinum itself is being credited back to us. I'd like to understand what is the case for vanadium for AMG.
I'll address that one. Metals markets are cyclical, like the price of oil. In a normal refinery and recycler relationship, maybe in the case of precious metals, these catalysts are leased to the refinery. I don't know that side of the business very well, but for spent resid catalyst, for example, there's going to be a long-term contract where there's a processing fee for the management of the hazardous waste, and this fee is offset by the value of the metals recovered during the process. And in a low metals price environment, there's likely going to be a net cost to the refinery. And in a high metals price environment, the net price is going to be a payment to the refinery for this waste. And one of the points we're trying to make here is the refiners really need to select a recycler and understand that the commercial arrangement between the two parties must be a win-win, and the recycler must be able to survive not only in good markets, but in bad markets. There's a lot of recyclers out there today who really act as swing producers, and you only see them knocking at your door looking for feedstock when the metals markets are good. Refiners really need to be able to rely on the recycling partner in all metals markets.
Thank you. You have another question, David?
Yeah, I think it was already answered partially.
Okay.
Since you are localizing this service in the region, are you planning to offer like a cradle to grave kind of service wherein the refiners will just pack the spent catalyst at site and AMG will pick it up and all the way to reclaiming and recovering it?
And that's it, Kevin. So basically, Dave, I think you nailed it. That's exactly what most of the customers are looking for these days, right? It's what we call cradle to grave or management system, catalyst management system, or full cycle. So basically, in Shell AMG, we are considering also to offer end-to-end solutions, all the way actually from supplying fresh catalyst and take the spent catalyst back to AMG facility in the US or in Middle East.
Thank you. That's all I have. Thank you.
Mohammed, you
Thanks,
mentioned
David.
about this cradle to grave, the catalyst management. Can you also explain what are the key elements the refiners should focus on to manage the potential liabilities of the catalysts, spent catalysts, once they leave their sites?
The key element really is to ensure that your processor has the proper funds available for proper closure of the facility, if they go out of business. But you also want to make sure that they are managing your material properly all through the process. Make sure that they're set up right. Make sure that they're doing the right things. And I really would strongly advise that you go back and look at the handbook that we have on our websites.
Thank you, Jane. We have a question from Talal Ashwal.
Good afternoon, everyone. My name is Talal Ashwal. I'm from Saudi Aramco Jazan Refinery Engineering. My question is regarding the soot ash rare metal recovery. Is there a certain threshold or concentration of vanadium in the soot ash where it becomes practical and economical?
Our understanding of the soot ash coming from the Jazan refinery, we understand you've got two different modes that you might run the refinery in, and the ash from Jazan is a very good quality ash. So I'd have to get more specific answers from our colleagues in Germany who are the experts in the gasification ash. However, so I don't know in that type of a process what the minimum is, but I can assure you that Jazan's ash, at least the information we have today, is well above any minimum levels that would present any concerns for our ability to process this material.
This is Firas from Samref. My question is regarding how is AMG ensuring the quality of the emission and effluent, be it liquid effluent or solid effluent from their plants?
AMG works very closely with the Environmental Protection Agency, both in the design and building of our facilities and in the operation of our facilities. So, we operate within our permit limits. We invest a lot of resources in managing our emissions. It is first and foremost our responsibility to the oil refineries to ensure that there are no environmental issues, and we recognize that and take that very seriously.
Jay, probably you can just give a number about the how much waste you get out of AMG plant in percentage ways. I think
we have zero liquid waste. Our solid waste is almost zero. I mean, when I did the math last year, we were at actually 99.7% conversion from raw materials to saleable finished goods.
This is Maruti from BAPCO. If you may, I just want to have make a comment and ask a question. I think this is, thank you for the excellent presentation. I think this is very timely. As we always speak, we have been speaking about this for some time now. I think in the refining sector in the Middle East, I think spent catalyst recycling or processing is possibly the weak link. The refiners spend a fortune in shipping the spent catalyst to Europe or to the US. So that's a big, shipping is a big cost there. So even if you have a roaster in the unit, that reduces the weight by half. So that's a big saving as well. So that's good and timely. So thanks for the presentation. Just a question: if you tie up with a refinery on, let's say, an X number of tons per month, and in case the unit has planned or unplanned shutdowns, how do we handle that? Is it like a take or pay on a fixed basis, or are you more flexible to handle that?
I mean, that's one of the things that we pride ourselves on in working with the refineries is we're here to serve the refinery. It's more challenging on the upside. But if you don't generate you can only send us what you generate. So there's not a real expectation that you would do more than that.
Okay, thank you.
Thank you. Thank you very much, everyone.
Raj, if there's no more questions, I just wanted to make one comment, which I thought might come out in the question and answer period, is about how much vanadium may come out in the Middle East from all these projects and how that might impact the market.
Please go ahead.
Anybody be interested in hearing
Please
a
go
little
ahead.
bit about that? Okay. This obviously depends on the technologies that are chosen in some of these projects. Some of them are still under study, as Mohammed pointed out. But based on our current estimates, we believe there's probably going to be between 10 and 15,000 metric tons of vanadium going to be recovered annually from this region, whether in region or exported. This is a significant amount of vanadium, considering the global production today is only something a little less than 110,000 metric tons. We showed earlier that global consumption is going to continue to rise and is going to be needed as consumption in steel is going to continue to grow, and the emerging market for vanadium batteries. And this growth in vanadium production is either going to come from increased recycling activities or primary mining, or a combination of the two. And vanadium consumption in the region, for example, I estimated currently at about 1,200 metric tons per year. As I mentioned also earlier, this is likely to double or probably triple by the year 2030. And then in addition to that, there was a project recently announced in the Kingdom of Saudi Arabia with a factory to build a sizable amount of vanadium redox flow batteries. And this market could consume every bit of the vanadium that's going to be generated in the region. These are massive projects, and this market potential in the region from vanadium redox flow batteries is quite significant. So, I think what's happening in the Middle East is a very exciting opportunity in the vanadium industry, and this industry is going to grow and evolve without a doubt locally.
Thank you, Kevin, for that insight into the volume. And I'm sure it has resonated with all our listeners. So once again, thank you very much, Kevin, Jane, Mohammed, AMG, Shell, and Mr. Suleman Al-Bargan, Mr. Ebrahim Talib, Mr. Auda Al-Ahmadi, and all the esteemed participants, our subject matter experts. It has been a very rich session of knowledge sharing. And for those viewers who have a question, and if they have not found any answer to their question in the session today, please do write to us using our info address, and we will come back to you with the answers from AMG. Also, if you have not seen any of our previous webinars, please go ahead and watch them. We have more than a dozen webinars on interesting topics with industry leaders. They are all available on our website, and you will find a link after this presentation, and go ahead and enjoy them. So with that, I bring this session to a close. I wish everyone to stay safe, stay healthy, and we hope that we'll be out of this crisis soon and we'll start meeting each other personally. Thank you very much. God bless.
Thank you very much all. Thank you, Raj.
Thank you. Thank you, everybody. Appreciate everybody's time today.